In this video, we're going to look at a number of properties of matrices. So let's recall how we add two matrices. Say A and B are m by n matrices. So they are matrices with m rows and n columns. Let's see be the sum of these two matrices. So what is C? Well, the ij entry of C is given by the ij entry of A plus the ij entry of B. So this means that addition is carried out component-wise. And here's an example. Suppose that these are my matrices 1, 2, 3, 4, 5, 6, and 1, 0, minus 1, 2, minus 2, 0. And if I add them, you add them component-wise. So this component here will be 1 plus 1, that's 2. And the next one will be 2 plus 0, so 2. And here will be 3 minus 1, which is again 2. And in the bottom row, I have 4 plus 2, that's 6. 5 minus 2, that's 3. And 6 plus 0, that's 6. Now, there are a number of properties that are worth remembering. So suppose that A is m by m, B, C, and D are m by n. Then the following properties hold. The first one is known as associativity of addition. So adding C and D first and then add to B is the same as adding B and C first and then add D. And the second one is known as the commutativity of addition. So B plus C is same as C plus B. And the next one is known as the distributive law. A times B plus C go A times B plus A times C. And there's another one similar. And B plus C times E is the same as B times E plus C times E, where here E is n by n. Now, the next set of properties that we're looking at concerns what is called a scalar multiplication of a matrix. So let alpha be a scalar. And if we're working over the real numbers, alpha will be a real number. And let A be a matrix. Then when we write alpha A, it is the matrix obtained from A by multiplying each entry by alpha. So for example, suppose we are working over the complex numbers. My scalar is 1 plus I, and the matrix we are looking at is 1, 0, I, 2. Then this represents the following matrix. 1 plus I, so I'm multiplying every entry by 1 plus I, 0. And here I have 1 plus I times I, so that's I plus I squared, and so I have minus 1 plus I. And here I have 2 plus 2I. And the way matrix subtraction is defined is simply this. We take A plus minus 1 times B. And the negation of a matrix A is defined to be minus 1 times the matrix A. There are a number of properties that involve scalars and matrices. Let alpha and beta be scalars, and A and B be m by n matrices, and C be a p by m matrix. Then the following properties hold. So alpha times A plus B is the same as alpha times A plus alpha times B. Alpha plus beta times A is the same as alpha times A plus beta times A. Alpha times beta times A is the same as alpha times beta times A. And C times alpha times A is the same as alpha times C times A. And that's the same as alpha times C times A. So those properties allow us to do a lot of simplification in matrix computations.